Today we're going to learn about the volume of prisms and cylinders. So let's go ahead and get started. Let's first talk about what volume is. And volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fit in the interior. So think of this as a bunch of dice. And if we pour in a bunch of dice inside of this figure, how many dice will fit if they're all touching the edges? Okay? Cavalieri's principle says that if two three-dimensional figures have the same height and the same cross-sectional area at every level, then they have the same volume. So even in this figure, it's up and down, and this one's more oblique. As long as this cross-section here is the same as that cross-section there, it has the same area, then these two figures will have equal volumes. So it says over here, a right prism and an oblique prism with the same base and height have the same volume. And the way you can think about this, the equivalent in two dimension is if we have a rectangle that is this base and that's height, then it has the same area as this if this is that height over there. Okay, so these two areas are the same. This area over here and this area here are the same, and therefore these two figures have equal areas. All right, so let's talk about the volume of the prism. There is a really good formula here that they're going to teach us. You'll notice right here that they use capital B, and capital B means area of the base. Remember that prisms have two bases, one here and one here. And so we label that capital B. And then the other thing is the prisms all have a height over here. So the volume formula for a prism is given right here. And you'll want to copy this into your notes, that the volume is equal to the capital B, the area of the base, times the height. And this is the same for any prism, including a cylinder. There are some shortcuts here. Here's a shortcut here. I lost my pen. If it's a box, as you already know, it's length times width times height. And if it's a cube, you just take the side and you cube it. So the volume here, we write down the formula. V equals area of the base times H. And then we write down the area of the base times height, because it's a rectangle. And this is the area of the base, which I'm going to call H1. And this is the height right here of this figure. Right here, that's the height. So this is the height here of the rectangle of the base. So let's go ahead and plug in here. The base has the shape of a rectangle with dimensions 13 times 3. And then we're going to multiply that times the height of the prism, which is 5. All right, and I don't think I have any special ways of multiplying this in my head. 39 times 5. So I'm just going to go ahead and do it over here. 13 times 3 times 5. And there it is, 195. And these are centimeters. And with volume, it's cubed, just like that. All right, let's go talk about here. Cavalieri's principle also relates to cylinders. You can see these two stacks of CDs have the same number of CDs, so they must have the same volume. It just happens that this one is a right cylinder, and this is an oblique cylinder. But because they have the same number of CDs, the volumes are equal, okay? So once again, the volume formula for a cylinder is the same as it was over here for a prism. You can see volume of a prism right here, area of the base times the height, volume of the cylinder there, area of the base times the height. But in this case, our area of our base is a circle. That's as hard as this gets. So let's go ahead and do this problem. So you write down the formula, which we're always going to do. You'll notice I use a capital H, a capital B here, meaning area of the base. All right, in this case, my base is a circle, so I substitute that in. And now I put parentheses for each one of my variables. My height of my prism here is 14 inches, so I'm going to substitute that in here. And here, the radius is not 18. What is the radius? That is correct. It's 9. It's half as much. So we're going to put a 9 there. So it wants us to give our answers in terms of pi and to round it off to the nearest tenth. It wants both answers. So let's go ahead and do as much of this as we can. So this is going to be 14 times 81 pi. And now on the calculator, let's go type that in. 14 times 81. And that's going to be 1,134 pi. And my units are inches cubed, or approximately times. And my pi is located here above the caret. And there it is. 3,562 point. And now, I'm going to bring this over here. So you can see we're going to round to the nearest tenth. If this one's 5 or more, and it is, we're going to add 1, and it's going to be 0.6 inches cubed. So there are my two answers. The exact answer and the approximate answer right there. Finally, we're actually going to skip that problem, and we're going to go look at a problem that we're going to be solving in class. But I want to set it up ahead of time. It says find the volume of a regular hexagonal prism. Round your answer. So the shape of the base is this right here. And indeed, they told us that it's a rectangular hexagon. So as we know, the volume formula for any prism is area of the base times the height. So we have to go find the area of this. And I'm going to go draw my hexagonal base right there. And the only thing we know is that's a 9, etc., all the way around. But we don't know anything else. And by now, we've already forgotten how to find. There was some formula, and there's a word apothegm, which I guess I'll describe right now. I'm going to go ahead and draw in these diagonals here. And I don't know if you remember, but this is each angle inside here is 120. So that makes this one here, I'm going to make a smaller pen. So this is going to be 60, and that one there is going to be 60, and that one's 60. So if these two are 60, also up here is 60. So we have 3 equilateral triangles. 6. 1, 2, 3, 4, 5, 6. Now, let's keep drawing. Let's draw a bigger picture of my equilateral triangle. I know that's 60. That's 4.5. And this is what we're going to call the apothegm. Okay? So if that's the apothegm, I can go use some trig now. Let's going to call this A. I need to know A in order to be able to find the area of this big triangle. So let's go find A. So it's going to be opposite and adjacent. So that's the trigonometric function tangent. Oh, I got a very thick one there. Tangent of 60 degrees equals, maybe let's bring this down a little, opposite all over adjacent, 4.5. Therefore, 4.5 times tangent of 60 equals my apothegm. So let's go ahead, now that we know trig, it makes it really easy to solve this. So let's go type this in. 4.5 times the tangent of 60. Okay, and the only thing I'm going to check is my mode, just to make sure I'm in degrees, and I am. Good. That was good. All right, so we found out my apothegm is 7 point, I'm going to give 3 digits here, 794. Okay? So that's my apothegm. So in each one of these triangles now, the bottom is 9, and the apothegm here is 7.794. So you can now go find the area of one triangle and multiply it times 6 to find the area of the whole triangle, of the whole hexagon. And then once you know the area of the whole hexagon, you can plug it in here for the area of the base. And then the only other thing you're going to add is that we know the height of the prism is this height right there. So that's your little hint to doing this problem in class tomorrow. If you don't remember about apothegm, go study right now and find apothegm. All right? Thanks so much.